Hello, everybody. This is Gigi, and I will be talking about geometric series today. All right, so let's get started here. Geometric series are the series of the form, the sum from 0 to infinity of an times some ratio r to the n power. Looking just like the geometric sequence, right? R to the n power is a geometric sequence. So this is a series. So we are summing up a r to the n power. So let's take a look at whether when it converges and when this diverges. And to see that, we should take a look at the nth partial sum. So suppose Sn is, right? So when n is 0, r to the 0 power is 1, so you just have a. And then a times r to the first power, a times r to the second, and so on, up until a times r to the n minus 1. And it's n minus 1 because if you're counting nth term and you start at 0, then, nth terms would be ending in a minus 1, yeah? All right, so what I'm going to do is, since this is an equation, I can multiply both sides by some number. And I think I'm just going to multiply both sides by r, the ratio r. So r multiplied by Sn is going to be looking just like Sn, except for we are going to start at a times r, and we are going to end with a times r to the nth power. All right. Now, since you have things that look kind of the same, what I'm going to do is I am going to take the white minus the yellow. So Sn minus r times Sn will equal to, what happened when I subtract? Well, this minus that is gone. This minus this is gone. This minus this is gone. This is going to be gone with something that is there. And this will be gone with the previous term to a to the r power. So all you end up would be the beginning of Sn and the end of r Sn, which is a minus a to the a times r to the n power, right? And you might be wondering why is it minus when it's a plus here? Well, remember what we were doing. We're taking the yellow away from the white, right? So that's subtraction. Doing a little bit of algebra, factor, and then solve for Sn. I would say that Sn is this expression here. Okay, so A, and we're going to focus on that expression because the next question we want to answer is, will Sn converge? When will it converge? And when will it diverge? So when we take the limit of Sn goes to infinity, this will depend on that right there, okay? That right there, which is a geometric sequence. And you've seen that before in a previous video, right? So we really are just thinking now, when does r to the n power converge? And that would depend on r. So let's go and take a look at a few scenarios here, okay? All right, so here it is again. And we are focusing on this part, okay? When r is less than 1, we know the geometric sequence will converge to 0. So the sum will just be a, this term here, multiplied by 1 over 1 minus r, which would be just a over 1 minus r. Okay, so when r is 1, we can't just go ahead and plug it into here, there. Remember that, because we need to go and look at our series. When r is 1, you will just have a times 1, which is a, plus a, plus a, plus a, plus a. And if you keep adding a into a sum, it is going to get bigger and bigger and bigger. So when r is 1, your series will diverge. Okay, now let's take a look at when r absolute value of when r is -1 actually. Then what are you going to have here in terms of our series? Well, we know that -1 to the odd exponent is going to stay negative, and -1 to the even exponent going to turn positive. So you are doing what? You are starting with a, you subtract a, that would be 0. And then you add a, so you'll be at a, and then you subtract a, so it'll be at 0. So your series, I would say the partial sums are going to oscillate between 0 and a. So we can't not say that it's gonna converge to one of those numbers, right? So we would say now our series diverge when r is equal to -1. Okay, so let's see again. When absolute value of r is less than 1, then your series will converge to a over 1 minus r. When absolute value of r is this right here, these two conditions really meant when absolute value of r is equal to 1, right? Your series will diverge. And now what happened when absolute value of r is greater than 1? Well, we know that the geometric sequence can diverge or there's no limit, right? So our series will also diverge. So case 1, the only case that it will converge is if the ratio, the absolute value of r is less than 1. And here's a summary of what that said. Okay, visualize that, think of that picture. Okay, so what's the difference if you want to relate back to your sequence? The geometric sequence converges at r equal to 1, where this one only converged in between -1 and 1. Yeah. All right, so here's the problem for us, and we'll keep that picture as a reference there on the right-hand side. When staring at this series, where you're this sum here that you're adding, you will see that E is everywhere. So we can factor out an E. And we factor out an E, then we would say, I see that it looks like 1 over pi here, being our ratio r, because this right here would be when r is 0, this right here when r is 1, right? When r is 2, look at that. So our sum is starting at 0 to infinity of e times 1 over pi to the nth power. Now, when does this geometric series converge? The e we can factor out, and the ratio r is 1 over pi, right? And we'll say, well, your a really is e in this case, right? So this will converge because it falls in the middle there, and it will converge to a over 1 minus r. So you will have that sum being e over 1 minus 1 over pi. We'll clean that up. That's a complex fraction there, so multiplying by 1. And your 1 would be pi over pi. When you clean that up, you would say, my geometric sum is pi e over pi minus 1. Nice. Okay, here's another example. When looking at this right here, 1/2 is your a, pi over e is your r, right? So geometric series, divergent or convergent geometric series depends on the r. So let's go look at the r. That would be pi over E. Well, we know that pi is larger than E, so pi over E is greater than 1, and we are there in that part of the number line. So we would say our sum diverges. Great. So your job is to recognize geometric series because those are very easy to deal with, right? And we are going to be talking about telescoping series next. So stay tuned.